stupid.
I'm stupid. What? Okay. So installing and using GNUPlot is actually surprisingly easy. Okay. So over there in the in CPS188 chat, if you look in pins, it's the first pin so far. It has the link to this page here to GNUPlot. I think you could probably just find it just by searching it up. Literally GNUPlot.info, primary download on SourceForge. There you go. It's right here. So download SourceForge. Yeah.
Is it the latest version so far?
Yes. The other ones will work. I don't think it's really relevant what version, but you might as well just download the most recent one, right?
Okay. All right, makes sense. All right.
And then open it up, allow it to run. Okay, so English, hopefully. Just go through it. There's not really anything that you have to change, really. Maybe enable Japanese language support if you're Japanese. Create a desktop terminal if you'd like. That's it. Install. That's literally it. GNUPlot doesn't come with like a ton of extra shit you have to disable. That's it. Finish. And it'll show up on your desktop. If it doesn't, you go here, you type in GNUPlot. So there's going to be two in your, when you search it up, there's going to be GNUPlot console version and GNUPlot no console version. Don't click the console version because it's, it launches like this, and you can use it like this, but it's not very clear. The not console version is better. That's it. Just the not console version is better. It pops up like this. And so this basically helps you, guides you along. These parts on the top have a lot of extra stuff, so that'll help you just like go through it and you see, oh, I can do this, oh, I can do that. That's how you do it. It does it for you. So how GNUPlot works is what do you call? It's basically a ton of commands, right? Everything you do here is just a list of commands. So okay, maybe I went a bit in front of myself. Okay, so first let's just get a basic plot going. So have some file, some what do you call it? Some location on your computer. And first you'll need a data file. So it's literally just a text document. So my data file. And you want to change the ending here to a .dat. You may not see that .txt at the end and can change it. That's just settings on your computer. You'll have to I think it's different on Windows 11. Let me see. How do you change it on Windows 10 even? I'm not prepared for this. Okay, so you can search up here, you know, how to show file extensions. I think I also I have the Windows 11 tutorial in here, but just search up. There are plenty of YouTube videos and all things if you don't see the ending here, because it needs to be a .data file.
Potatoes? I got a question.
Sure.
My shit straight up fucking crashed. Like it doesn't work for me. Like, is there a fucking fix for that and shit?
You installed it like this?
I installed it and it straight up just fucking crashed on me, bro.
When you launch it, it just like pops up for a second, disappears, or what's up?
No. It just says like directory not found. Like, did that happen to you or like?
Oh yes, if you install it and then you click launch after closing, it will do that for some reason. Just launch it. Just go to your search bar, launch GNUPlot again.
Thank you, Father.
Yeah.
Thank you.
GNUPlot.
Gotcha.
Yeah, there you go. So, so it's two parts. Yeah. So the first one is a data file. And again, Windows likes to hide this last part from you, so you'll have to search up how to show file extensions. Once you do that, you'll have all these file extensions at the end of the files. So now just open it up in a text editor. So if I go here, double click it, it'll ask, how do you want to open this file? Show more apps, find a notepad or whatever. Literally, data files and GNU files are just text files. They're just named differently so that you know that one's a data file, you know that the other is for GNUPlot. So Data files are incredibly simple. You'll have to primarily make them in C, but I'm showing you this as an example of how they'll look like. Your first column will be the x-axis, right? So you have 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth. And then space, and your second column. So let's have 10, 20, oh, I put 2 spaces there. 30, 40, 50, 60, 70, 80. A really simple graph, right? Stupid simple. So if we want to plot it, we go GNUPlot here, and the first thing we have to do is set our directory. So GNUPlot needs to know where our data file is. So go to File, change directory, and now find, find where on your computer this is. So mine is basement working GNUPlot here. And you see it runs the command for you. So again, all of these things at the top are here to run the commands for you if you don't know what those commands are. So use them to your advantage. So once you're in here, now type in plot. Actually, let's not type that. We can just go here, plot. Oh, it doesn't fill it out for us. Shit. So here we type in plot space, and now your data file. So it's my underscore data file dot dat. You need to have these what do you call it? Double apostrophes, quotation marks, using. Okay, so the first number is the column of your x-axis. So this is our first column here, 0, 1, 2, 3, 4, 5, 6, 7. So that's going to be 1, the first column, right? Then colon, and this is going to be your y-axis now. So we're going to use 10, 20, 30, 40, 50, so on and so forth as our y values. That's our second column in our data file. So 1, column 2, title, and then you put in the title of your plot. If we run that, you see that GNUPlot opens up a window with the data. That's literally it. So that's the basis of GNUPlot. This is the command you'll be using the most. Plot data file using x-axis, column, y-axis, title. Now, let's say that we have 2 plots. We have 2 y-axes, right? So if we were to draw that out, we would have our graph like this. We'd have 1 plot like this and maybe 1 plot like this on the same graph. So there's 2 ways to do it. The first one is to have 2 data files. So let's make a second data file. Make a text document, name it datafile2.dat. Open it up in Notepad. And let's type in 0, 1, 2, 3, 4, 5, 6, 7. And then our second column will do 70, 60, 50, 40, 30, 20, 10, 0. And by the way, just to repeat myself, these data files you shouldn't be making by hand. I'm just showing an example. I'm just showing an example writing it out by hand. So to plot 2 files, 2 separate files, so we have our first data file and our second data file, we go here, and you can use the arrow keys to go back and forth, up and down between commands you've recently sent. So we take our previous command, plot my data file using 1, column 2, using title plot, and we repeat it. So quotation mark, data file 2.dat using 1, column 2, title plot number 2. So once again, this takes the second data file that we have, using the first column as our x-axis here, the second column as our y-axis here, and then we title it plot number 2. And if we run that, we can see we now have 2 plots along our GNU plot. So that's one way to plot multiple data sets onto the same graph. And now, there is a second way to do this, and the second way is to use one data file entirely. So let me just delete this data file too. And in our old data file, we give another space and another column. So once again, this sort of acts like a table of values, right? Like an Excel spreadsheet. Our first column, our second column, and our third column. And now instead of writing what we wrote before, we use the same data file, so my underscore data file .dat. So these two lines, or these two data sets, come from the same file using 1, because that's our x-axis, and now our y-axis is our third column here. So using 1 colon 3, title plot number 2, and we have the same thing as before. So there's two ways to plot it out. You can either plot it out in the same in the what do you call it? I say that too much. From the same data file or from two separate data files, and that's how you do it. However, this graph is bare bones. It doesn't have a lot of information. It literally just has our two data sets and the name of our data sets. So we can augment our graph using GNUPlot commands. And again, these tabs at the top will help you a lot. So for example, I can look over here, style, data style. We can change here, lines, points, lines and points, dots, and impulses. So let's do lines. There you go. So it runs set style data lines. And now if we run the GNUPlot again, the same command that we ran last time, we get lines. Lines between the points. These, let me just change this to make it more obvious. They don't curve the line, so it's just straight lines between your data points, right? And likewise, we could go here, styles, lines, and points. I have to do it twice for some reason. It failed the first time. There you go. If I repeat it, you can see it shows the points and the lines at the same time. So, what GNUPlot is, pretty much, is that we send in a bunch of commands of how we want our graph to look, and then we run the plot command. The plot command is always the last one. And once again, we can go here, we could go, okay, we want the X label to be, years. Offset, so just do 0, 0, because we don't really care about that right now. I have to run it twice for some reason. Where is it? X label. There you go. Years 0, 0. There you go. It sets X label years offset 0, 0. These things at the top just sort of fill out the command for you. And once again, if I run the plot, we have the X label at the bottom. So play around with these stuff at the top, especially axes, chart, styles. We're not doing 3D, so you don't need to worry about that. And so now, say you want to share this file with someone. You don't want to send them this whole thing. You don't want to send them a list of these commands and then this at the bottom. So what we do is we create a GNU file. So go to your place where you're working, right click, new, text document. And once again, create a GNU file, .gnu. It's going to complain, ignore it, and open it up as a text file. It's just a text file. So what a GNU file is it's just a list of commands. It's just a so remember here how we do set style data lines, set X label years, offset 00. This, when we tell GNUPlot to run a GNU file, it just runs the commands in it. So let's just copy the commands that we sent in here. Copy clipboard, paste. Oh, that one's already. There you go. Copy clipboard, and then paste. And then the plot command is always the last command in your GNUPlot. So copy clipboard, paste. So this is my GNU file, and you see it's just a list of commands. Set the data style to lines, set the X label, and then plot it. Save. And then now in GNUPlot, run load I keep on forgetting what you call these, quotation mark GNU file.gnu, and close. And you see it runs the commands all for us. If we close GNUPlot, let's open up GNUPlot again. So we have a fresh start of GNUPlot. We go file, change directory. We go back to our where we save everything, and we will run load GNU file.gnu. You see it loads everything, including the X labels, including the style lines, all of that fun stuff. So one thing you will have to be careful about is that because this is just a list of commands, is that there's no difference between this being typed in series and this being loaded from a GNU file. So let's say, for example, we forget to send in lines, and our client, in this case a university, wants our data to be in lines. So you might be working with all this stuff, and on the way you set the data style to lines. Paste. And then while you're testing your data, right, you run GNU lines, or you load your GNU file, and you see there's lines. So that criteria has been met, right? So you send it off, and then the client opens it up, the university, downloads your GNU file. Here. And then they load the GNU file. There's no lines. Because you ran it in your terminal, so your GNUPlot remembered, yeah, the next graph needs to be in lines, but it's not in the GNU file. So it looked right to you, but it's not right. So let's repeat that same mistake we had before. So we had set data style lines, and we run our GNU file. It looks correct. Before sending it off, when you test it, type in reset. So that resets all of the commands that you have sent, and then just load the GNU file. And you'll see exactly how it will look like in a fresh startup of GNU file. And so now you'll look at your GNU file, and you'll go, oh, I forgot to add lines. I have to open up my GNU file, set data style lines, save it, and now when I load it, there are now lines. So that's the entire tutorial on GNUPlot. Like, that's literally it. All of your other effort will be spent in generating this data file. So you should be able to make a data file like that in C, but just as a refresher, right? You make a file in, you fopen, sorry, in is equal to fopen myfile.dat. Is that it? Oh yeah, commands. You have to give it write permission so you can write to it. If I send you my code for finding the individual entries, can you optimize it? No, I can't. I can help you with it. I can help debug, but I can't optimize for you. Also, you can unmute if you want. I don't really, especially to ask questions. Okay. You don't want to talk to me? I'm sorry. Damn. I didn't think I'd be rejected like that. So anyway, just as a reminder, you run fprintf, and we can do %d space %lf, our data, right? So we have our first column here, our second column here. Let's add a third column as well. And then at the end, don't forget to add a new line. Because if we go back to the data files, you can see it's in new lines, it's in rows, right? So you have to have a new line at the end. Don't save. So let's put this in a for loop. Int I is equal 0, I is less than 101, I plus plus. And we just print in I, let's do square root of I. And here is going to be the exponent. Actually, no. Let's do 2 times I. Why is it complaining? Incompatible. Oh. Let's save that as an integer as well. So, oh, oops, forgot to fclose. Don't forget to do that. And now if I go to where my code is running, open in Explorer. Here you go. After I run it, I'm using cline. It'll be the same in Genie. It'll be the same as everything. It's going to be next to your exe file. You'll have your data file. So let's copy that. Can you show briefly how you cut out the Oh, I'm not working in CSVs yet. This is just generating the data file. But I'll talk about that in a second after this, right? So we go here, we paste it into where we're working in GNUPlot. We can look inside. All of our data is set. And now let's plot myfile.data using 1:2 title square root, comma, myfile.dat using 1:3 because we have 2 datas in here, right? We have the square root and we have 2 times. Title 2x. And you can see here we have our graph. We can zoom in, all of that fun stuff. Make sure to check the auto scale feature here, right? Because if it's too zoomed in, you might not see all of your plot points. You can have grid lines, all of that fun stuff. And again, use all of this to add titles, labels, all of that fun stuff. So that's how you make a data file through C. That's it. So right, you want to talk about CSV files. So first of all, the first thing to notice that I've noticed a lot of people don't actually notice. You get CSV file, you open it up, it's a spreadsheet, right? But it's not actually a spreadsheet. If you right click on it, you can open it up with Notepad. So open with Notepad. And you'll notice it's actually just a bunch of values separated by commas. That's exactly what it stands for. It stands for CSV, comma, separated values. So there's a couple things you can abuse with this. First of all, is that every single row has the same amount of cells. So if I go here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you check every single row of this file, I don't expect you to, there are 9 cells per row. So how can you interpret this CSV file? the same exact way as a text file. So let's open it up. So my CSV.csv. Actually, let's use the actual name of it. Global temperatures.csv. Copy. Paste. Let's read from it. So let's printf, or let's fscanf right now. In %c percent out, or sorry, and out. Let's make a char out. Then we can print out what we get. And nothing happens. Because actually, the CSV file isn't actually there. So, so you have to go to where your code is and put CSV file next to your code. Nothing still happens because it's not next to your code it needs to be next to. It needs to be next to your executable file. So I noticed this because someone had asked me, took a while to figure out, is that he couldn't open up a file. And the reason why is because he had his CSV file next to his C file. But the executable is in a different folder. So make sure that your file, your data, all of your stuff is next to your exe file. Do I have Helldivers 2? I don't. I need to buy it, but I have no friends. So there you go. Now we can read from it, right? So how can we interpret, how can we split up this? Yeah, I know it's really good. I played Helldiver 1 like a ton when it came out, but how expensive is Helldivers right now? I think it's like $40. Yeah, I know it's good with randoms, but I'm also introverted. Anyway, so to read from this file, we can use a couple functions. The first one that's incredibly useful is what do you call it? It is, oh, what was it? Oh, fgets. So fgets reads a whole line from a file. So it reads one whole line up until the end of it, the enter key, right? So fgets, let's see, char buffer. Okay, so let's do char out 512. You can do any length you want, it doesn't matter. Out 512 and in. Oh, it gets it, but I don't print it out. Oops. So printf %s. If you want to press string, is %s, and then out. And there you go. It printed the one entire line from our CSV file. So you can use that to read one line from any text file. Right? Just keep on repeating that for every line. If I run that again, if I take this and run it again, you'll see it gets the next line from the CSV file. Now, another feature that you can use to read from a CSV file is strtok. If you're ever confused about function, you can search it up. So just do C strtok. Literally just get the first link. There you go. Tells you everything. Declaration strtok. So let's say we have this is a complete hypothetical. Let's say we have some char info 512 is equal to hello world, how's it going? And we want to, just hypothetically, we want to split up this string by the space. You know, let's do something else. Let's do by this weird apostrophe. single apostrophe. Oop. We can use strtok. And it's going to complain because I need to include strings. Is it strings or string? Let's see. It's strings. Okay, so we pass in our info, right? And then we pass in a character. Oh wait, let's not use this because it gets confused. Let's use a period. Why are you complaining? Ignore that. So oh, I probably should have searched up how this works because I haven't actually tested how strtok works. Well, that's fun. We can work through it together. So we can get that. We could do a char star token. And we can now do that token is equal strtok. So that does something, I think. Why is it complaining? Oh, okay, you have to give it a string. So you have to do char deliminator, at least length of 2, and let's give it a period. Oh, there you go. Delim. Okay, so that's how you set up strtok. And so just by searching up, you could see that Wagar is a delimitator. Are you asking what is a delimitator? What is a delimitator? Oh, that's just the thing separating the parts that we want. So we want to take this text here, this string here, and split it up according to between these periods. Right? So what's this here? Okay, so now if we take this token, let's see what happens if we print this token as a string. So let's do %s and then token. And you can see it prints out the first value that we have here. So so then we can repeat this. So the way that this is repeating, as far as I can tell, we run the same thing here. We pass in null here. And we repeat this. So let's see if that works. Yeah, okay. So we run str token, or str token, yes. We give in our info string, so in this case, hello.world.house.it.dows.going. And then we give in a delimitator. So again, that's the thing that separates the string from what you want. And now you fill in a token, so that's a char pointer. Token is equal to that string token. And then you print it out. And you can see it prints out the, is a delimitator 2 because of dot and null character? Yes, actually, exactly that. I don't know what will happen if we give it 1, but I don't, yeah, it gets annoying. Because I don't know if you remember from the thing. Well, you clearly do because you said what happens. Strings are just a list of characters. So for example, if we do char2, that's a string of 2 characters long. And the first character we have a period, and the second character we have a \0. the null character. And again, that null character is just say end of string. It takes up a character, so it needs to be 2 characters long. So that's why we give it 2 length. Bigger than 2, it doesn't really matter. You can see it makes no difference if we have 5 or 4. So yeah, we have our delimiter, so that's the things that separate. Token. And then we print out that token. And we get the first item in our list, separated by items, separated by periods. And if we run token again with null as our string, it will give back the token again, or give back the next token, in this case, world. And we can just repeat this process for as many times as we want. It prints out hello, then it gets the next item, world, then the next item, house, then the next item, no, it, and then the next item, going. So that's how you split up a string separated by periods or whatever you want. This could be anything, right? This could be G if you want, or H. Actually, we don't even need to repeat H because there's like a couple H's. And you'll see again, it'll split up by the H's. So in this case, LO, then world, then how's it going? And it removes the H's as well. So that's how you split it up using strtok. So now the next part that might be useful about reading CSV files is that let's say you have a string with a number in it, say 20.30. Let's printf %s info. And you can see it's 20.30. It looks like a number. Let's treat it like a number. So info plus 2. Info is equal info plus 2. It breaks because it's not a number, right? It's actually a string of 2, of the character 2, then the character 0, then the character period, then the character 3, then the character 0. So we need to find a way to turn this string into a number. And thankfully, C has functions for this already. The first one is atoi that turns. Oop. Why are you complaining? Okay, so atoi is part of stdlib, so standard library. It's not in std. So you have to go to the top and include standard library.h. So atoi, and then let's give an our info. Integer value is equal to atoi. And now we can print this out. Or sorry, value. As an integer. See, 20. The second one is atof, which returns it as a double. So let's change this into a double. And you can see it reads 2030, it turns it into a double, and you know it's a double because it posts a ton of zeros afterwards. By the way, this might be useful in one of them, but you'll notice it always posts 6 periods afterwards. You might, if your value is smaller than that amount, you might have to tell it .8, for example. So print 8 characters. 8 characters after the period. Because if I make this like really small, you'll see. You'll see it rounds it to 0. So you may have to make that longer. Anyway. So another cool thing about atof is that say we have characters afterwards, even if we have a number after it, it will ignore all of the characters and it will just read what it can. So it'll read 20.30, it sees these letters and it goes, I don't know what that is, I'm going to ignore the rest of this. So Those are 3 things that may help you read that CSV file. So just to recap, you have fgetS, you have strtok, and you have atoi or atof. It is also possible to do all of this with fscanf. I would not recommend it. It is a pain in the ass. But it is possible. Definitely is. Okay, is there anything else we want to go over? Or anyone wants to go over? Okay, I'm going to say that's a no for now. Is there anything... I'm trying to think what else I was considering going over. Can you explain problem 2 of the lab? Yeah, sure, but I don't know if there's too much I can help with that. There's, if I open this up... Oh, that's the wrong one. Lab 7. So there is problem 2 here. The formula is given to you, right? You have all of the values here, and then you're asked to make this graph. I pretty much helped you with this. So I showed you how to make the GNUPlot and the data file, and you should know how to calculate R from this. So is there like any part you want me to go over? Two people are typing. Maybe review how to print it into a new file. There's a Q2 for this. Yeah, there is 2 questions for this lab. Only 2, however. So it's less than most of the other labs. What do you mean you never saw another page? Well, good luck with that. But yes, are you going out? Alright, see you. Oh, okay, yeah. So, just to review printing, for example. You have to open up a file, you have to give it the right mode, right? And then, you have to print to the file. So let's do, just remember fprintf, right? And then the format you want, %d, %lf. Can you go over displaying all the values from the file? Sure, I'll do this like in one go. So from here to there, I'm going to show you how you create the data file, open it up in GNUPlot, and then give all of the stuff. So let's say we have 3 values, 4 values here. So %lf, %lf, %lf. I use strtok. I'm not sure why you should be... Are you talking about question 2 of the lab? Because I don't think you should be using strtok in question 2 of the lab. Because you're not reading from a file. So let's do a for loop here. Int I is equal 0. Oh, and a new line. Don't forget that. I is smaller than 100, I++. So let's go here and let's say double value. So actually, let's make this an LF as well. So double x-axis is equal to I times 0.000001. Let's see. Add an extra 0 for good measure. Oh, you're talking about the final project? What do you mean that only some of it displays? Are you talking like only one line or one cell or only half of the CSV file? Just for reference to show it here. Only some of it displays. Okay, hold up. All right, so I'll just finish this and then I'll get back to that. So we have a double x-axis, right? And let's do double first column. Let's set that to exponential of the x-axis. Let's do double of the second column. Let's do power of 10 to the x-axis. And then double of third column. Oh no, let's do 2 times the x-axis. And so now let's print this out to a file. So we do x-axis. Just again the convention of making your first number the x-axis. Then we have the first column, second column, then the third column. Why are you complaining? Oh, I have to give the file. I'm stupid. There you go. So fprintf in the format. Is normal variable naming convention with C underscores instead of camel case? Yes, but it doesn't really matter for this course. It shouldn't really matter. For those who are confused, he's asking if you should name something like double third column or double third underscore column. It doesn't really matter, but the convention, like the standard way in C, is this lower one. So it's word underscore word, so on. So fprintf, all of this stuff, and then we close it. I accidentally wrote that to global temperatures.csv. If I open that now, you'll notice it's just all of my data. So let's rename that. Save it to data file. So test.data. So let's run this. There you go, test.data, and once again we can open this up and we see all of our values here. Actually, I'm going to remove this third column. Let's change it to something else because I noticed that the scale is going to be weird. So let's do 5 here. Test.data. Actually, 1 second. Let's subtract 1 because once again I know the scale is going to be a little bit weird with graphing. Okay, so this is a reasonable file you might be made to make. Now, one thing off the bat that you will notice reading through this data file, let's look here. You'll notice that all of these values are 0 for the x-axis. What's up with that? And I mentioned this before. This is because you're being cut off, right? There's a 1 here, there's a 2 here, there's a 3 here, there's a 4 here, there's 5, but it's just being rounded off because by default, printing LF only gives you 6 digits of accuracy. So you have to go here and give 0.8. Or you can print it out as a %E. I haven't really tried that, but apparently that's one way of doing it. You'd have to look into that, search it up online. So, once again, there you go. See, now all of the x values have different x values. So now let's make a graph from this. So let's copy that, move it to our GNUPlot folder. What did I open here? Whatever. And let's open GNUPlot. So let's have our data file on the right and GNUPlot on the left. So our first column is our x-axis. So let's plot test.data using 1 column 2. So this is our second column. So first column is our x, column 2 is our y-axis. Title, e to the x. And then our second column, or this is actually our third column. Our third column, our second y value. Let's repeat again. So test.data using 1:3 title 10 to the x, and then comma, and then repeat this again. That's all it is. Using 1:4 title 5 to the x. And you can see it prints out all of the graphs, all of the data. You'll see it all will automatically scale your data to fit the data set. So you won't really need to worry about that. You see, it even formats to the power to the x for you. And once again, we can do set x label x, set y label y, title my dumb graph, set title my dumb graph, and then plot it. And you can see it prints out all of our labels, all of our information. And then, right, let's close that out. Create a new GNU file. So test GNU file .gnu. Open it up in Notepad and just copy over the commands that you said that you want to use. So set x label, copy clipboard, paste. Set y label, copy clipboard, paste. This one wasn't right, so we'll skip that. Copy this one, paste, and then copy this plot and paste. We save it. And now even if we boot up a clean version of GNUPlot, so let's do GNUPlot, change directory. Load test GNU file.gnu, and we get your graph. So, oh, well, I forgot to set the data line. So, what was that? Styles, data style line. It keeps on forgetting to put the first character, but if you run it again, it does it properly. I don't know why. So if I run it now, there you go. There you go. Now it appears as lines. So that's start to finish, writing up a program that creates a data file, booting it up into GNUPlot, plotting it, giving it the extra flair that it wants, and then saving it to GNU file. Okay, so what's this problem you're having? So this person's saying he has a problem. When I do this, I only get this as my output. That looks right. What's the problem? Oh, does it finish only after 1750? Then most likely you aren't repeating it enough times. Can you zoom out? Can you like take a picture zoomed out? You can send it through DMs if you want. In the meantime, it might be useful to review a bit more about strings, because strings are also a little bit complicated in C compared to the rest. Let's see. Sorry, I'll have to check that out later. I don't know why your code is stopping halfway through. So contact me after so I can actually like test it out. So I'm going to just review over strings and then probably going to be done for the day unless there's anything else anyone is confused about. So, oh sorry, what? Or is there any other concept you want me to go over before we finish? I'm going to take that as a no. So, just one last review on strings. So remember that strings are just a list of characters. So we have, let me draw this out. So we have characters of, say, 20 length, of this amount of length. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 characters. So this is a list of 15 characters. And when we set it to something like hello, right, it goes one character at a time, saves in each one of these sort of boxes. You can imagine a character array as a list of boxes with one character inside. And then it fills the rest of it with this value, the \0. That's the null character. The null character is there to tell you, by the way, it's a \0, that's not a 10. The null character is there to tell anyone reading the string that you've reached the end of the string. Don't go further. Because, remember, it doesn't actually know how long the string is. You might know that you have to do something like str, what do you call it, len. Str len gets the length of the string. All str len goes is it reads how much characters there are until it gets a null character. It doesn't actually know how long the array is. So that's why the null characters are there. What that also means, just as I said before, is that if you have a character array of, let's say, 3. So you have 3 boxes here. That means you can actually only store 2 characters. Because if you store, what do you call it, by, for example, it will store BYE, but there's no room for the null character. And when you try to read the character, the computer goes, okay, I'm going to read this string until I see a null character. Keeps on going. It doesn't find a null character. It just finds whatever happens to be there. And then eventually your computer notices that it's doing something weird and it shuts down your program. So you need to have at least 4 characters here so that you have a null character that will tell the computer stop. And you can set that manually if you want. So say, for example, you have this character here, hello, right? If you go here and you run that char2, actually 1, is equal to the null character, it will take your string and it will input the null character there, right? And then if you try to print this string, if you try to read the string or see how long it is, the computer will read H, go see the null character and realize, oh, we're done. It ignores the rest. So therefore, your string is now H. Even though L, L, and O are still there, as far as the computer is aware, there's only H. And I can actually show you that right now. If I create char str15 is equal to hello world, let's print that out. So %s str. Let's give a new line there. And then I go, what do you call it? Let's do str4 is equal to the null character. Again, this is a character. I know that you put in 2 characters, so it seems weird, but according to the computer, this is 1 character. semicolon, and then we do printf, %s, and once again we print out the string. Why are you complaining? Oh, comma. You'll notice we replace the O here. That's the 5th character. So remember, it starts at 0, so this is the 5th character we're changing into a null character. The computer prints out H-E-L-L. Oh, that's a null character. I'm going to stop. It doesn't really care what's after the null character. So there's that. Make sure to be acquainted with the string library, because string library has a lot of very useful things. So once again, strlen was one that I used here. Right, so let's do int len is equal to strlen. Len's length. It's just shortened length. And we can print out %d of the length. And once again, let's repeat that afterwards just to show that that you don't really care about what's after the null character. Oops. You can see here, this is 11 characters long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it hits a null character that stops. And then this one is only 4 characters. 1, 2, 3, 4. Sees a null character, it stops. So that's strings. Don't go over the length of a string, obviously, or else your computer will get very mad at you. I can actually show what happens right now if, let's say that, let's make this 11 characters long and try to print it out. So again, this is exactly 11 characters, but there's no longer room for the null character. You'll see it keeps on going, but I guess it interprets something else as a null character, and then it just stops. But you'll see it starts spewing random stuff afterwards. And then the computer tells it to stop. So there's that. That's pretty much it. And once again, don't go over the limit or else your computer will get angry. Is there... I think that's about it, really, that I can cover. Is there anything else that needs to be covered? There's recursion, but I think... should I cover recursion? And I'll cover recursion just for the hell of it. Because, I don't know, maybe someone else might be confused on recursion. Oh, are you typing? No? Okay. So, recursion is really simple. So if you have some function, all recursion does is it calls itself. So, you have main here. It calls function, right? And then you make function call itself. This is entirely allowed, and you can repeat this for, I think, a couple thousand times before your program crashes. That's literally just the entire concept of recursion. The only thing you need to be careful of, the only core part about recursion, is that you need to make sure that you don't call your function infinite times, or else obviously you're never going to finish. So at some point you need to make some sort of if statement that if this call itself, so function, all that stuff, else stop. Actually, you don't even need to write anything. So let's just take a really simple example of recursion. So int count up. So all this does, it takes an integer and integer in, and then the integer goal. Actually, let's do integer rest. So all we want to do is count up that many times until we get the answer. This is literally just addition, right? So we take in some in, and then we add 1. And now that we've added 1, so in is equal to in plus 1, we want to count up again. So we call count up in. Pass and rest. Now, we don't want this to run infinite times, right? So now we need to do a check. So if rest is not 0, so if the remaining amount, let's do remaining, is not 0, we subtract remaining here, is equal to remaining minus 1. Yeah, so we go, okay, let's count from 5 times. So we count up to 6. Now we need to count 4 remaining times, and then we repeat ourselves. Then 7, 3 remaining times, 9, 2 remaining times. You get the idea. Oh, and then you return this value. Was it complaining? Otherwise, just return in, right? So if we don't have anything more to do, we just return the value. And we can go, okay, printf, %d, count up from 5 times, and it will print 10. And we can show this every single time if we put a printf in here. So let's do %d, value %d, remaining %d, in remaining. And you can see it counts up. So 5, 5, then it goes 6, 4, then 7, 3, then 8, 2, then 9, 1. So that's recursion. That's it. It's literally, recursion is just calling itself. And I know that the next thing that's going to be said is, that's stupid. Why would you do that? Honestly, yeah. I don't know why you would do this, but sometimes it asks you to, so you do it. Alright, I think we're done for now. I don't think there's anything else for me to cover. For now, there's nothing left for me to cover. Alright, so if there's no more questions, I'll just wrap this up here. Have a good day, everyone. Oh, there's a question? Alright, you too. Alright, you too, man. I'll stop the recording now.